Okay, question 6 is a very long question. It's an O-level question, but there are multiple scaffolding questions to help you solve it. So, what actually happens here is you have the hotter object here, which is the 50 degrees Celsius water. This 100 gram of 50 degrees Celsius water, it will cool down ultimately to 46 degrees Celsius. And where does this energy go to? This energy goes to um, melting an ice cube until it's all 0 degrees Celsius water, and then raising the temperature of this 0 degrees Celsius water from the melted ice cube to 46 degrees Celsius. So first part, you are to calculate the energy lost by the water, the 100 gram water, as it cools down. So use the specific heat capacity equation, plug in the value, and again watch out for the units. In this case, it's alright to use grams because the value of the specific heat capacity is given in grams also, and with that you can get 1680 joules. Now in part B, we switch our focus to the melted ice. So the melted ice is actually at 0 degrees Celsius after it melts to become water. And it will heat up to 46 degrees Celsius, which is the final temperature of the whole mixture. So you are to calculate the thermal energy needed for it to heat up to 46 degrees Celsius. So again, use the same specific heat capacity equation, plug in the values and get 580 joules of energy. Now, if you look at the top, that is a conservation of energy equation, which is what I mentioned just now. Essentially, um, the hotter object actually loses thermal energy and give away this thermal energy to the colder object. So the hotter object in this case is the 50 degrees Celsius water, and as it cools down to the final temperature of 46 degrees Celsius, it gives out this thermal energy. It gives away this thermal energy, and it gives it to the right hand side of the equation, which is the ice. So all this energy is used to, number one, melt the ice completely, from 0 degrees Celsius ice to 0 degrees Celsius water. Plus, the energy is also sufficient to then raise the temperature of this 0 degrees Celsius water from the melted ice only, and raise the temperature to 46 degrees Celsius. So, what you are trying to find out in this question is actually the latent heat needed to melt the ice, which is this part of the equation. So, this we have gotten from part A, this we have gotten from part C. So it's a simple subtraction really, if you understand and can apply conservation energy here. So that's how we can get, using a subtraction of your answers in part A and part B, we can get the latent heat of uh, fusion, which is essentially just the energy needed to melt the ice, to be 1100 joules. Okay. Now in part D, with the latent heat of fusion found in part C, you are to find the specific version of this. So use the only equation for latent heat, which is over here. Plug in the mass value, and because you use a mass value in gram, that's why your answer for specific latent heat is joules per gram, and that's how you can get the answer.